In this episode of Finno Ugric machining, we are going to make a groove into the tailstock, the quill holder part, and the groove is for the gear rack, and this, well, but before we do that one, we have to glue this one into here. Oh, it's yeah. And before that, before gluing, we need to clean this up really properly. And before we can clean it, I noticed that my surshot is it's empty. We need to fill it. Well, you are going to see how I fill it. So, and after all these operations, we really can go into the making the groove, and this will be somewhat interesting. It's like measuring how to put it into place, because this groove should be quite tight. It should be a sliding fit, but there shouldn't be too much play in that one. So, okay. So let's first fill in the surshot. In order to fill this, you need something to open this thing, and I'm using my. And don't open it fully. If there is a pressure inside, there is a hole in this one which allows the pressure to come out. And when it stops hissing, then you can screw it out. And it goes without saying that you should keep everything clean. You shouldn't let any dirt go into there. That's a bad idea. And well, I have a funnel which I place here. Well, that's quite simple. And then I have this stuff, which is CRC fast dry degreaser. It contains naphtha and acetone. Well, what you shouldn't put into there is some corrosive liquids like paint remover. That would be really bad idea. Generally, any water-based things should be bad, are bad for this one, because it's not stainless, it's not proof for acids. And furthermore, when you fill it in, you should keep the fill about this level, not higher, because you need some air space in there. And this seems to be almost end. I need to get a new of these. Let's see now, where are we? It's dark inside. So let's take one measuring stick, just see that it doesn't contain any dirt. This is just a welding stick. If I put it down in there, so I can see that now we are about here. It's about the correct now. Never fill it fully in. Filling that one fully in is a bad, well, you shouldn't, because it doesn't work well if you do that. And then put this one back. And this is almost empty. Well, maybe one refill. And now, this doesn't need to be very tight. It's just almost like finger tight, but not tighter than that. Then you take away this black cap. And I have made an adapter, not made, this is rescued from broken bicycle pump, which I can put into this one. You put some soft air into there, like that, and then I put it there, and now it's charged. There you are, ready to go. It should work. Yeah. And put your cap back. There you are, filled, ready to go for the next job. Okay, now, well, let's glue this thing. First we need to sterilize these parts. This one I already wiped it off with a clean cloth, but it still contains, I can feel it, some grease on it, so I just put quite liberally this stuff into there, and then with a very clean cloth wipe it clean. Nothing came out, which was expected. Yeah, now I shouldn't touch that one. There will be some hammering going on here, so therefore a little bit tighter. And I actually prepared this gear rack. I stoned it, all the burrs, if any high spots off from the sides. And I also stoned the corners, so that if they rise any burr when it goes down, that would be a very bad thing. This is just some red stone, Indiana maybe. And same goes with this one, it should be sterile, so to say. And again, oh yeah, that's done. And now, well, this is some Loctite thread lock 2701, but before I hammer it in, I really would like to check which way, because I noticed it goes better the other way. Well, this might be good. Well, yeah, it's definitely the other way around. Okay, so now I just put some glue on the bottom, because it's a flat surface. When I squeeze it, the glue spreads, should spread all over the place. So let's see if I can get the glue out of the bottle. This is this green stuff. So, yeah, not a lot. Well, not a lot. And then it was this way, so now I just place it there, and the purpose of this glue is to prevent it from moving axially. So now, well, it started. And I will do the rest with the vise. Like this. And now let's see. Well, it was already in the bottom. Wow, that was a lot of force. Well, it should be in the bottom all the way, really, because otherwise it won't work well in the quill. And I'm using this scrap aluminium. Well, it sounds solid. It sounds really solid. it's there, I believe. I can see the glue coming, and this one gets markings from the gear. Well, it's there. Won't come out and won't go more in either. So yeah, it's there. We have a gear rack here. Now what I could do, I could measure, and I will actually measure that it's plain, but there is nothing much I can do if it is not fully in. Is it fully in? Well, yeah, okay. I will now measure it and see if, well, yes, I will measure it. Well, I was a little bit afraid of measuring it because, well, if it is not in place, then it's not in place. But let's see. Well, I actually measured it already, and so this one reads 43.14, as you can see. Hopefully this, yeah. And it was about here, and then here, well, 43.16. So I think if we have 14, 16, 200ths of a millimeter deviation in thickness in these 2 points, it's straight. And now the main event, so to say. This one now has the gear rack in it, and obviously there is a round hole, and it goes this way in. When it now goes in, it's very tight fit. So, well, obviously we need a slot under here, inside, in order for it to be able to travel there. And now, since I don't have a shaper, and I don't have any means to mill, any means to like machine that into a round hole, that's next to impossible for me. With a file, yes, ready in the next century, yeah, but this is in 2 pieces, so I can take the upper part off. And this is really tight, I know already. Oh yeah, no, not that tight. Oh yes, it is. I already took it apart, and that... please, okay. The bolts are out. And now you should be able to take this away. Yeah. So what I have done here already, I stoned these edges. These are like super sharp when I first took it out. These were really bad. And now it's there. So now we can mill it. No trouble at all. It's like putting your end mill into here and milling it. And I think we have enough room here as well. Yes, we do. So now it's child's play. Yeah, but of course you lose some of the rigidity, yes, and there is this trouble of putting it back together, yes, but this is the only way I found that it is possible for me to do this in a way. So now, and these, I already almost got an injury out of these. Stoning is essential here to make these not sharp. So now next thing I will put this into the milling table accurately, and it should be really straight. Fortunately this surface here is our reference surface. We can use that one. Okay, I would like to show you how I dial in this workpiece into this table. And so for this purpose I have here, first of all, how I attach it. I have two of these two clamps, another will come here when it's dialed in, and then I have these things here, which these are loose, these are tight. And actually these are tightened so that this end cannot move in the Y direction. And so the idea here is that it is pivoting from this end and not from here. Well, and this two clamp is semi-tight. It's not really tight, it's just creating some friction for me so that it's easier to bump. Because my adjusting tool will be this. And now let's do this. It's actually quite simple operation. I will show you the dial indicator. There you go. And since we start from this end, it will be 0. So let's put that into 0. And very important, lock the Y direction. If you don't, then when you bump, you will be actually moving the table and not the workpiece. Okay, and now just go this direction. Okay, it's not in place. There is some deviation, I can tell. Well, of almost 0.1 millimeters, so we need to bump this way, just like that. And now let's go back. Well, there is, seems like we have 1/100th of a millimeter deviation at the moment. No, 2. So let's zero it again. Well, there you are. Like that. And then we go again. Always measure the same way. Well, there is some, still some from this side, and you have to be really gentle. Okay, that's more than enough. I will now tighten this a little bit more so it doesn't want to move so much. Well, what do you see? Let's assume that's 0. I think we are inside, yes, we are inside 1/100th of a millimeter. Okay, next step, I will tighten it and redial after that. So now this is straight, and it is inside 1/100th of a millimeter, maybe better than that, maybe inside 1/100th of a millimeter. That's the figure here. So what I have here is a mechanical edge detector, which I will be using now to find this edge. And I will show it to you with this camera, like that. And well, I have this paper here in the back to prevent it from focusing into these things in the background. It did that. Well, that's the purpose of that. So now let's find the edge. It's a really simple thing to do. Funny sound. Not the same. Oh yeah, now it's the same. Let's try third time. Now it's there. Okay. Oh well. Now that we have I will take this away, don't need it anymore. So the next step is of course to move it, first of all, move this so I don't break my thing. And now we need to move it 3 millimeters this way, the table. So 1, 2 and 3. There you are. 3. I will lock it there so I don't move it accidentally. So now, and as you notice, this doesn't need to be so tight. Well, just that it is straight, so that's everything that is needed. Oh, now this paper is now. So, last time when I bored the hole, I used to measure 39.79 millimeters. So I will zero some things now. This one for the first to zero. Yeah. And then this one to some even centimeters here. And this is really horrific. Okay, now I can look from there the coarse, and then the fine I will use that dial. So 39.79. So 10, 20, 30, 39 is there. And then 70, 20, 40, 60, 70 and 9. Okay, that would be 9. And lock it there. There you are. Now it's in a precise, well, it should be in a precise place. And then what I'm going to use to mill this one is this, this is Niagara 1/2 inch end mill, full carbide. So hopefully we have clearance. Yes, we have. Of course I checked that one. This is horrific. If you have in this, it has happened to me multiple times. When I do this kind of thing, I dial everything in place and measure, and then I put the final end mill here and find out that, oh shit, I cannot do this because there is not enough clearance. Okay, so this should be clean. This is clean. Yeah, and this time I'm using the ER25 collet because it's smaller. I could use the ER40 here as well. and this one should be tightened really well, because now it's a bad thing if it moves up or down. So let's tighten this one. There you are. Wow, we are quite ready to go. Measure this one. Yeah, okay. So I can take measure from this top how much it's just by putting this here and pushing it against the rack and then putting this down. And now I have here some 9.1 millimeters. So I know that from this edge to the top of the gears it is 9.1 millimeters. So, and now I have the end mill which has been touching, just touching the surface, and this is at the moment it's a little bit lower than this one. If I mill 9 millimeters, that should be quite near. What I will do here now is to set the automatic stops like here is the first. Where is my tool? It's there. So it will be going this way. Oh, wait a minute. Going that way, going this way. So that stop is our... I always mix up these. And about there. You can actually use these to stop it in inside 1/10 of a millimeter, and that's quite good. And obviously this is in a wrong place. There is our place now. It stops there now. Okay, these are now set. Okay, now it's going. So now it's a 9mm deep groove in there. So what I need to do now is to widen it a little bit. I made some calculations. Well, oh yeah. So this is the groove now, and this is what it should be. It should be 13.90 millimeters, yeah. But it is at the moment 12.75 millimeters on average. The surface finish is so bad that, well, I got different readings all over the place, but this is a good average. And so when we subtract from that one, we get the difference of the fights. Then I split that into two. I get this is the difference, and this is how much it should be on each side. So now it's 0.575 millimeters, and I already moved the Y direction using this dial indicator. And now I'm going to mill it, and it will be higher speed and lower feed and client milling, and I'm not comfortable with this mill because it has 0.4 millimeter slack backslash into screw. It might become a problem, but with very slow speed feed and very and the cut is only 0.5 millimeters, but it's 9 millimeters wide nevertheless. So let's mill. Okay, so now we have a very good groove. I tried it out and it slides there quite exactly. There is a little bit of play, but so it should be. Well, now I will diffuse this setup, and then I will deburr this one, and then I try to put it together and see whether it works that way as well. Yeah. in case you wonder why I'm wiped so thoroughly these ways, the reason is that this type of milling produces sharp needles, which you don't want to have on your skin or anywhere. They are really painful. So that is the reason for that kind of thorough cleanup. And for your environment, geeks, the metal goes into the bucket and the paper goes into the... Of course there are some metal residue in the paper, but yeah, okay. So, now deboring. Yes. Well, you can put it together. You need one hammer blow into this corner and then it settles down. And now it's really tight in all possible ways. Like it doesn't rotate at all. I cannot feel anything here. So, well, maybe the oil makes it so that it doesn't feel. But anyway, it's smooth and really smooth actually. This episode of Finno machining. And now we have a decent groove in the quill holder. It's I would say as precise as I can make it, and I doubt there are more than 300ths of a millimeter play in there. And it travels smoothly all the way through, so it is straight. If it would be somehow kinked, it would start like jamming, binding. So no binding, it works smoothly, has no play. Well, in the next episode of Finno machining we are going to start creating the pinion, and this one is a shaft that's going in 90 degrees to the it will be driving that gear rack. So that will be in the next episode of Finno machining, Till then, bye!